Okay. My name is Mark Köslin. I'm working for ProXES as an application specialist, and I'm glad to welcome you to our second webinar, which we developed together with IMPAG. We would like to get to the next journey from lab to production with focusing incorporating powders. And before we start with the presentation, I would like to mention that your audio and video is automatically switched off. If you have any questions, please use the Q&A function of Zoom. And for your information, this webinar will be recorded. I would like to briefly introduce our speakers of today. At IMPAG side, we have Ms. Stefanie Beisler. She's responsible for product development and strategic marketing and is working in the formulation laboratory of the IMPAG Group. And we have Céline Roté. She's the leader of the sales and product management, and she's also responsible for the personal care segment. On ProXES side, I have to excuse today Eloise Muff. Instead of Eloise Muff, my colleague Martin Koch will do a part of this presentation. He is head of our Process and Technology Center in Neuenburg am Rhein. And I also introduced myself. I have also a part in this presentation. And now I would like to introduce you to ProXES, to the ProXES group. So ProXES are three machine manufacturers, Stefan Machinery, Turlet, and Freimer Kuruma. The group was established in 2015, but each of the company has a quite long history. And we are active in the field of personal care, pharmaceutical, and food industry. So we are doing processing units for all these industries, like multi-purpose units with homogenizers, vacuum systems, and many more. We got 9 subsidiaries worldwide, and we have an annual sales of approximately 100 million, and all over the world we got 100,000 machines installed, more than 100,000. With this slide, I would like to highlight our training and technology centers around the globe. We have 2 training and technology centers in Germany, one in Neuenburg and one in Hamelin. In Asia, we got 2 in China, in Shanghai, and in Singapore, and one is coming soon in Mandalay, US. And in our training and technology centers, you can perform, for example, feasibility studies. You can test your application under real condition. We can do the optimization of current processes and products, and you are kindly invited to join our technology centers, where we have all the equipment and different scales available to perform any kind of study. And now I would like to hand over to Ms. Stefanie Beisler from
Thanks,
IMPAG.
Mark. Yeah, some facts as well from IMPAG Group. We are a well-known ingredient distributor with a strong presence in the European market, I would say. For more than 100 years, we have grown into a successful company with long-term partnerships and exclusive partnerships as well. With our technical expertise, we can offer you a wide range of raw materials for the life science area and as well for the material science area. So please contact us here for any information or questions. Especially for the personal care market, we advise and supply our customers with high quality active ingredients and functionals, and in that way we can offer individual solutions for face and body care, such as cleansing products, hair care, sun care, oral care, or color cosmetics. And in Germany, or more precisely in Offenbach, Our fully equipped and modern laboratory is located, and this allows us to offer you technical formulation support and strong raw material expertise in developing a wide variety of different formulations with full stability testing. So, but now I don't want to talk too much about company facts. I will show you our agenda and what you can expect from our webinar today. At the beginning, I would like to show you an overview about common powder ingredients for cosmetics and different incorporating methods and difficulties with it. My colleague Celine will show you some exciting product information about titanium dioxide, zinc oxide, and suitable emulsifier systems. Then I will go on with the production of our multifunctional zinc cream in the lab. And afterwards, our partners from ProXES Group will show you the pilot production process and key manufacturing processes such as deagglomeration, grinding with different mills, for example, and mixing. In the lab and also in the production, a lot of powder ingredients we come across, and this can be UV filters, pigments, texture additives like silica, peeling particles or powders, active ingredients, also surfactants or common filling agents for color cosmetic products, for example. All these powder ingredients have to be incorporated into a formulation in the end, or this is our main goal. There are various ways in which these powders are processed, and of course there are also different challenges. Texture additives, for example, which we use for a nice skin feeling or in general for texture improvement, should be incorporated while stirring or homogenizing. Pearlescent or a pacifier for some color effects will be incorporated while stirring. The same applies for powder surfactants or for solid cleansing products like these instant product which you can mix with tap water at home. Here you can also process with mixing or by using an extruder. The milling process in general used for pigments to color the skin or the texture, or for filling agents like kaolin, which is an anti-caking ingredient. You can also work under simple blending. Titanium dioxide is well known for coloring the skin or as a mineral UV filter. It will be incorporated also by milling or homogenizing. The same applies for zinc oxide, which is well known as an anti-inflammatory active ingredient and also a mineral UV filter. By working with all these powders ingredients, we have to be careful with dust formation to protect us and as well our environment. Some powder ingredients tend here to agglomerates or hygroscopy. So we have to be careful with coatings and special raw material characteristics. And sometimes powders comes with unequal grain sizes, which also can be problematic for our formulation. Our partners ProXES will give you also some tips for handling powders in batch sites, but now I hand over to my colleague Celine from IMPAG for some really exciting raw material or powder ingredient facts.
Thank you, Steffi. So following the presentation of each kind of ingredient, we will have a little overview on the portfolio of ingredients that we can offer at IMPAG, especially on the titanium dioxide. First for the sun care, because titanium dioxide for sun care and for color cosmetics are not always the same. The good point of titanium dioxide is a broad spectrum ingredient for UV protection with a very good stability. Most of them are Cosmos compliant. We have two different types of titanium dioxide. The first one is the GRTD2. It's not a powder directly. We offer it as a dispersion, but even if it's already dispersed, it's still a challenge to formulate with it. It gives a very good sun protection and a good transparency on skin. The second type of titanium dioxide, it's the T80 series. For this one, the importance of the ingredient is that it's able to bring a nice UV protection, but also coverage, thanks to their silica coating that can very link the particle together. So it's the perfect powder for the BB and CC cream to give coverage and UV protection. We can also offer it as a dispersion for the people who want maybe a more easiest way to incorporate it into the formulation. Then we will go to the titanium dioxide for color cosmetics. So here, the most important is to have the coverage on the skin, but we also need a very nice skin feel, which is not the easiest with the titanium dioxide because usually it's a strong particle and it can be not very smooth on the skin. Here in our portfolio, we offer a range of titanium dioxide with a special coating with the lauryl lysine, which gives a very nice skin feel. And we also use the technology of linked with the silica with the snow titan. The snow titan, it's we have a picture of the snow titan on the right. It's particles of titanium dioxide that are linked together to make it bigger and smoother, but still with the same effect on the skin and the same coverage. With the lauryl lysine, we have a Cosmos compliant and 100% natural raw material. We can also offer it with the alkylsilane coating for the product that contains silicone. Then the second overview as a powder is the zinc oxide. So zinc oxide, it's also a UV filter when used for it. It is interesting because it's more transparent than the titanium dioxide. You can see it on the picture on the upright. The good point of the zinc oxide is that it gives a good protection against UVA and UVB, which is more and more important on the sun care product because you must have protection of both UVA and UVB. It's stable, no photochemical reaction. It's odorless and it's really suitable for sensitive skin because it doesn't penetrate on the skin. So it means less reaction and less allergy. For this zinc oxide, we have a lot of different products depending on the coating. Some of them are coated, some are not. The coating can be not the same as stearic acid or acetyl alcohol, but the most important is the form of the powder. Some zinc oxide are really round and other zinc oxide, as the Senzidino Oleo 200, is a rod shape. And the form of the particle give a different sense feel. And also not always the same sun protection. It's better if you can just mix it together. And we offer it also in dispersion if you need to incorporate it more easily in the formulation. The zinc oxide is emulsion. It's not always easy to handle because it tends to thicken over time, it's then very important to pre-disperse the powder in an oily phase. Even if you work with already with the dispersion ingredient, it's really important to work on the oily phase to have a stable product at the end. Our recommendation is to work with the water in oil emulsion. It's easiest to stabilize it. And we have the best emulsifier to do it with the Oleamils WO or the Neocare P3R. It's both emulsifier from the polyglycerol technology. On the right, you can see a graph of the stability test we've made on formulation with the viscosity, with a small increase of the viscosity at 40 degrees, but a very stable one at the room temperature and the 6 degrees. It's the challenge, but we can really succeed to hit it. And our second focus will be on the emulsifier portfolio, where we have a very lot of different emulsifier with the oleamils, sesamuls, and avomuls range. Depending on the HLB, depending on the melting point, you can have a lot of different texture or with water in oil emulsion or oil in water emulsion. We can have hot process or cold process, also depending on the emulsifier. We will have a more focused slide on the oleamils water in oil, which is the emulsifier we use in our multifunctional cream. Oleamils WO, it's a polyglycerol 6-pentane oleate. It's a non-ionic emulsifier, palm-free, PEG-free, China compliant, and Cosmos. So with a very nice trend of natural cosmetic and organic cosmetics. It's come from olive oil, and the polyglycerol is from vegetable origin. With oleamils, you will create the emulsion with liquid crystals, making it very smooth and very glossy, so very nice appearance. Is thanks to the polyglycerol technology, it helps to have a very good dispersion of pigment and sun filter on the oily phase and on the emulsion itself. For the formulation tips, we very advise to use oleamils WO in the oily phase, and as usual for the water in oil emulsion, we recommend to add an ionic agent in the water phase as sodium chloride or magnesium sulfate. It really helps to stabilize the emulsion. Even if it's with the cold process, we use the Ultraterax for the emulsion to do it. But Steffi will talk a little bit more about the process and how to do our multifunctional emulsion.
Yes, perfect, Celine, thank you. Now we come to the lab product of our multifunctional zinc cream, which is based on water and oil emulsion, especially the Oleamils WO, which Celine already explained. Hereby, we worked with the maximum of powder ingredients, to especially the zinc oxide, to show you how we proceed here in the lab. As you can see, phase A contains the emulsifier and some emollients, the preservative agent and antioxidant, as well as a stabilizing agent. Phase A needs to be heated shortly to 50 degrees to solve the preservative agent here. Otherwise, you can proceed cold. Afterwards, we prepare our water phase, phase C, and heat also to 50 degrees. In between, we can prepare phase B, our premix of an emollient, and the zinc oxide Sunsnow Oleo 200, which is the maximum of zinc oxide here, 25%. You can steer this premix a little bit by hand, and then we use a triple roller mill to get a very homogeneous phase here. In this way, we are very well prepared to combine the different phases. Therefore, we add the premix from our triple roller mill to the oil phase while stirring. Afterwards, we can add phase C, the water phase, to phase A, B under homogenizing with an ultra-Spirox, and you will see that shiny emulsion is formed while mixing for around about 2 minutes. Now the emulsion can slowly cool down under gentle stirring, and if you like, you can add some sensorial enhancers like Sunsil 158H in the end. Here I want to show you a little bit more in pictures what we did with the high powder phase here in the lab. Picture 1 shows the procedure of adding the zinc oxide to an emollient. Phase 2 shows the pre-dispersion step of milling the premix to an homogeneous phase, which is, we learned, very important for our stability. Afterwards, you can add this, the zinc oxide oil premix to the oil phase under stirring and go on with the emulsification process for your emulsion. Here we will have a short video. So please start. Thank you, Mark. Here you can see the prepared premix with zinc oxide and the emollient, which we used here in a triple roller mill. And you can see here this very shiny premix, which we added here to the oil phase in the beginning and stirring. Afterwards, we will add the water phase to our oil phase under homogenizing. And you can stir a little bit by hand as well to make sure the water is incorporated very well. And now you can see a very nice, shiny and light emulsion has formed. Thanks to our very nice emulsifier system, Oleamus WO. Thank you. Now I hand over to Mark for the part of ProXES. So it's your stage.
Yeah, thank you very much, IMPAG team, for this very interesting first part. I think we all learned a lot about the different ingredients. And I would like now to take over and stick directly to the topic which was discussed in the slides before. So the laboratory trial with a multifunctional zinc cream. For this reason, we met up with IMPAG in our Training and Technology Center in Neuenburg am Rhein. And we did the transfer of the technology from laboratory scale to our pilot scale. And for the dispersion and grinding of the zinc oxide suspension, we used our bead mill technology, which you can see on the right-hand side. This is the cobalt mill MS12. And for final emulsification, blending, and deaeration, we used our vacuum processing unit, a Dynex H lab, which you can see here in the middle picture. We also did a video, and I would like to show you now how we performed the trials and give you some insights about the pilot scale. So the first step was to premix the phase B for grinding. It is the emollient and the zinc oxide. Then we prepared the cobalt mill, feeding the beads. Now we adjusted the parameters of the mill, and on the right-hand side, you can see the feeding hopper where the suspension is. Directly behind there is the pump, and the pump feeds the product into the mill. And on the upper left side, you can see an animation how the working principle of the mill is. So the beads are getting in rotation due to the high peripheral speed of the rotor. And then we are grinding the particles to a very narrow particle size distribution, which gives us a very good stability in the end product. Particle size was measured with grindometer, and the result was less than 5 micron. This is our Dynex technology, the Dynex lab, where we performed the emulsification. The first step was to feed the pre-grinded phase into the main vessel, phase B, via the hopper, via the main lid. And then we prepared phase A in our side vessel. We added the oils and the Dermosoft GMC. We heated up to 50 degrees in order to melt the Dermosoft. And then we added the zinc stearate. Here we have to mention that this does not go into solution, so we have white particles, but as soon as it enters the machine and it will get in solution with the water phase. Now we are transferring phase B into the main machine where phase A is already in. We have a gentle blending with a homogenizer on moderate shear speed, as you can see. Now we prepare the dispersed phase, the water phase, for emulsification. In order to have a very fine emulsion, we increase the speed of the homogenizer to a high shear rate. And then we gently fed the phase C into the homogenizer. After that, we have a final homogenization time to create the small droplets. Now we got a deaeration of the product in order to get a smooth and shiny surface. You can see the air bubbles are rising and the product level is falling over time. So we remove the air from the product. And here you can see a very shiny and smooth cream, which were produced with our equipment. Some facts about our trials. So as I already mentioned, we used the Cobalt MS12 for the zinc oxide suspension. We pre-mixed the zinc oxide with cetiol using a dissolver disc. The throughput was 44 kg per hour, and the total powder content of the suspension was 55%. We gained a particle size of less than 5 micrometers according to the grindometer. And interesting fact is that we had a higher viscosity compared to the triple roller mill. This is not a disadvantage in our point of view. It is more from advantage because with lowering or with hiring the viscosity, we as well increase the viscosity of the final product, which leads to a higher stability and less use of additional stability agents. So for the cream production, and this means emulsification, mixing, and deaeration, we used our unit Dynex H Lab. We had a little premix vessel with double jacket for preheating phase A, and already mentioned the final viscosity was a little bit higher. And in general, it was a easy and quick procedure. With this slide, I would like to show you the difference between a grinding and deagglomeration process when we are talking about powder processing. If we talk about a grinding process, it is primary grains or primary grain fragments, and we are really reducing the particle size of each particle. So we are cutting the particle into smaller pieces, and which results in a smaller or in a smaller particles and a certain particle size distribution, which differs from the initial material. While the deagglomeration is a little bit different. So it's, for example, flocculates, agglomerates, or aggregates, and usually these powders having already a quite fine particle size distribution, but they are sticking somehow together due to intermolecular forces, for example. So you can imagine it can be thickeners like xanthan, which are building lumps, or other powders which are sticking together. And by adding shear via a homogenizing system, we can distribute these particles homogeneously into our bulk. I would like to start with the deagglomeration process of the powders. And at Frei-Makuruma, we have two different ways of deagglomerate powders. We have the batch-wise production and the inline production. First of all, I would like to focus on the batch production. So we are using our Dynex technology, which you saw on the trials. It is a multi-processing unit, so it can not only deagglomerate powders, it can emulsify, it can mix, it can heat and cool. So we have a multifunctional unit which can process emulsions, suspensions, and so on. For feeding the powders, the vacuum is the driving force, and vacuum is created by a watering pump. The suction of the powders is directly in front of our dispersing unit, the homogenizer, which you can see also on the left upper picture. So here's the inlet, there's the inlet valve, and the powders arriving directly into the shear zone, and we get in contact and disperse the powder already during the introduction. High shear forces already mentioned in the rotor-stator system dispersing the powders. Important is also the powder flow rate, which is controlled by the opening angle and the vacuum adjustment of the unit. And we can feed the powders via a hopper or a special powder suction lens if we talk about larger fractions. Compared to this, you can see on the bottom our inline technology. It is a powder intake and dispersing unit, the so-called POWDIL. It can be installed on existing installations of the customer to improve your process. You can imagine if you have a very insufficient mixing unit, you can install this inline homogenizer to improve the process. And here as well, vacuum is the driving force, but there is no vacuum pump needed. Vacuum is created by the device itself. And all the next points are very similar to the batch unit. I would like to highlight the homogenizer. So it is a very, this is the Frei-Makuruma homogenizing principle, which is the same in both units. And to understand the working principle, we prepared a little 3D animation for you, which I will start now. So in this 3D animation, you can see the deagglomeration process in our homogenizing system. So we feed the powders directly into the homogenizer. There we have a premix zone where we pre-disperse the powders. Then we got the dispersing zone and a pumping zone at the end. And now we are looking a bit more into the rotor-stator system where we apply the shear forces. So the rotor is rotating with a high velocity. And in between the rotor and the stator, we got a narrow shear gap where we introduce the shear and where we reduce or where we disperse the powders and reduce the particle size if we talk, for example, about emulsion droplets. This is should show you that we can achieve a very narrow particle size distribution when talking about emulsions, for example. Yeah. And I would like now to give you some insights about different parameters which are influencing the incorporation of the powders. So first of all, I would like to talk about the shear rate, which is introduced via the homogenizer. You must know that our homogenizing systems can run from 600 RPM, which is the lowest shear force, up to 3000 RPM, which is the highest one. And according to the type of powder, we should also modify the homogenizing speed. So if we introduce a thickener, for example, xanthan gum or any other gums, we would recommend to increase the speed to at least 2500 RPM. And if you have also large quantities of powders, more than 20–30%, we would also recommend, even if it's not a thickener, to increase the homogenizing speed in order to transport the large powder portions into the circulation line. and in order to also to avoid any kind of blockage. If you have material which is shear sensitive, for example, we can reduce our homogenizing speeds to, for example, 1000 RPM. And if a temperature rise is not acceptable, you can also reduce the speed. Or if you have some powders which tend to foam, as an example, we can take your surfactant, sodium lauryl sulfate, for example, then we would also recommend to reduce the speed. Just a brief introduction about our batch unit, which we use for personal care industry, and which we also use for the trials. The Dynex H, so the homogenizing principle I already introduced you to. Generally speaking, we have here a closed system with an integrated vacuum system and also integrated cleaning. We feed the raw ingredients via vacuum. So vacuum is the driving for the pressure difference is the driving force for feeding the ingredients into the system. And we feed the particles usually, or the ingredients directly into the homogenizing zone, as already explained. And then we are pumping the product into the recirculation line, and we can choose between the short circulation and the long circulation. The short circulation is for flexible batching as well as for foamy products. You can circulate underneath the product level, and the long loop is for improved top-down mixing. We've got a double jacket for heating and cooling. It can be steam or chilled water, for example. There's a scraper agitator system in the middle of this main vessel. We can scrape to improve the heat exchange. We have a horizontal mixing inside the vessel. And yeah, with this unit, we can produce a lot of different personal care applications, from low to high viscosity, emulsions, suspensions, toothpaste. So yeah, it is a very versatile vacuum processing unit. Talking about the vacuum and the feeding rate, which is as well important for powders, we have different recommendations. First of all, according to the size of the equipment, if the size is rising, the larger the vessel, the more vacuum should be adjusted. This has something to do with the counter pressure, which is created by the water column in the main vessel. And in addition, we should lower the vacuum level if we have very fluffy powders like silica with a low density, or if the aqueous phase is hot, so to avoid boiling inside the vessel. And if we have the tendency to foam, to decrease the level of liquid. Higher vacuum level should be used if the material to feed is viscous. An example of a sticky powder is Titan dioxide. It is very compact, and there we would also recommend to use higher vacuum values. Regarding the feed rate, I just want to give you here some insights. These are general recommendations. So with rising machine size, we have also larger diameters of our homogenizing system, and this results in higher feeding rates. And in general, we can say that thickening materials should be fed slower compared to non-thickening materials. And these are our general recommendations, but also it can differ a little bit from type to type. But this is a good point to start off if you have a new product, for example, and you would like to feed any kind of powder. You can regard this. The reason why we feed thickening material so slow is that we would like to achieve a direct dispersion, and also that the homogenizer can handle the amount. So we give always a portion to the homogenizer and disperse it immediately. This reduces also the overall time of dispersing. Now we switch to the inline technology. As I already mentioned, we got here our, by the way, newest development at Pharmacoruma, the PowDil. It's an induction and dispersing system for powders, which can be connected to existing installations, for example, as you can see on the right picture. So we have a unit also with a table where we can place some bags on it. And directly next to it, we got the powder hopper. And due to the vacuum, which is created only by the device itself, we can suck in any kind or most kinds of powders which are in the personal industry present. And in addition, we have a pumping capacity like with our batch units. So we can connect, for example, a circulation line on inefficient mixers, and then we can circulate and increase the performance of your unit. This is the working principle of the PowDil. So we have a base liquid which is recirculating through the system. So the pumping effect is coming from the pumping impeller, which turns with up to 3000 RPM. And due to the special construction here, we've got a strong vacuum which will be created, and the powders can be fed directly here in front of the homogenizing system, and we can realize suction rates between 0.1 and 0.5 kg per second. With this slide, I would like to give you some examples of powders in the personal care industry, which can be fed with our system. It can, for example, be sugar for any kind of scrub, or zinc oxide, as we already mentioned. Also, thickeners are possible. Carbopol, for example, can be fed with the system, or also gums like xanthan gum, and also silica is possible. But we have also to mention, if the viscosity is rising, we need to add a positive displacement pump to the system in order to still get a recirculation. At the moment, we got the size 160 developed, which you can see on this table, but also other sizes are under development. This is a little summary of what I've said, and I suggest that you can read this by your own. You get also, after the presentation, a mail with the PDF file, and this is a very good summary in order to see what we're talking about. Okay, now I'm coming to the end of my part, and I would like to pass the word to my colleague Martin.
Thank you very much, Mark. So we are approaching the end of our presentation. And before we go to the discussion part, I would like to take the chance and to present you in the next couple of minutes the other field of our machine and processing portfolio, the wet milling equipment. What you see on this slide is our milling cascade. So you see from left to the right our milling cascade. So from coarse to very fine, we offer suitable equipment for many kinds of applications. On the left, you see a picture of a perforated disc mill. This is a device for raw material pre-processing, very coarse grinding. So for example, whole aloe leaves can go in, whole fruits, vegetables, for example, potatoes, to achieve starches and functional proteins. The next technology is the tooth colloid mill, which is well-sited equipment for milling and also dispersing. Corundum disc mill, very resistant equipment for fine grinding application. And last but not least, on the right side, our annular gap mill, which is working with milling beads. You have seen it in the slides before, to process the pigments, the particles, for very fine grinding. Here is a picture of the tooth colloid mill. You see the equipment is based on a motor that drives a rotor with a special type of toothing, which transfers the energy on the application. On top of that rotor is a stator positioned, which we can adjust by a gap adjustment. So we can adjust the particle size of the application, and also the shear stress which is applied on the product. We have a temperation function, so a coolable housing to keep the temperature under a certain limit. And we have also an injecting device installed, which reacts as a certain pumping impeller. Yeah, so we can also pump the product further to downstream steps or into buffer vessels. The mill can be executed with various rotor stator shapes. So you see it is a three-staged technology, so 3 stages of certain toothings to break the product stream, to have an additional cutting event on the particle or droplet. On the left side of the picture, you see a cross-toothed device, which brings the finest milling results, because we have here the largest cutting area. This mill exists from very small laboratory scale, which you can handle on a table, up to very large devices with a diameter of 250 millimeter of this grinding tool for very large capacities. It is a very hygienic equipment made of stainless steel, and the elastomeric part as the sealings and gaskets. We have also wear resistant execution for abrasive applications, which we call remanite. Here in the pictures, you see an extract of possible applications. The machine has a B modality. We can, on one hand side, use it as a mill for particle size reduction. So again, the topic of this agglomeration, or primary grain grinding. By adjusting the gap, we can achieve various particle sizes. And the other functionality this device has is the dispersing ability. So this mill is often also used as a dispersing device to create suspensions and also emulsions. And on the right picture, you see a potential setup for such tasks. So in combination with a vessel where we load liquid and solids, or continuous and dispersed phase, we can use the pumping effect of the mill and recirculate the liquid and feed further phases in order to create a high quality emulsion with this device. You see a couple of examples here for applications. And I would like also to highlight algae. Yeah, in the seaweed field, the perforated disc mill and the tooth colloid mill are used as a combination in order to process seaweed to extract alginate, which is also often used in the cosmetics, or in particular in the personal care field. But we can create also decorative products such as BB cream, for example, or other examples of this field. This is a sketch of our annular gap mill, the bead mill. The brand name is Cobalt Mill. This is where we made our sunscreen application with. The applications for this technology are in particularly products which require a very narrow particle size spectrum and which are also temperature sensitive. You see all the blue fields. These are tempered surfaces of the equipment. You see this surface is very huge. Temperature critical products run very well on this equipment. You see in yellow the milling gap where we add the grinding beads. And so we bring the beads into a dynamic by using our rotor, and the beads do the milling tasks. So in between those white milling beads, the particles are moving, and the beads and the particle itself, they move to each other and do the particle size reduction job. This is an inline equipment, so we run through the mill, and here on this slide you see here our milling material, various milling beads, so round beads made of various materials, glass beads, steel beads, ceramic beads, very resistant, high abrasive products can run through this product with minimized wear. You see in the center on the top a picture of various rotor materials. Steel is possible, ceramic is possible, wherever metal ions are not acceptable. Also elastomeric coatings are possible. And I would like to highlight also that we have an execution in silicon carbide. So an extremely hard material for extremely abrasive applications. The mill exists in various sizes, and it is very versatile, very flexible in applications. So from nutritional supplements, like for example, soft gel fillings, minerals and vitamins, but also for decoratives such as lipstick mass. Also pigment pastes are milled to achieve very intense, very bright colors, and also in the application we have seen today in our presentation. Thank you very much in the name of all of us for your interest so far. It was our pleasure to present to you raw materials, machines, potential applications. And now there's the time to face your interesting questions to us.
Thank you very much to the whole team. And now we have the opportunity to answer your questions for sure. We have all the experts here from ingredient side and process side. And we have, I will take a look. Yeah, more than 10 minutes to care about your questions. So please use the Q&A function. And I already saw there were some questions from customers. So one question was in French. This I think is something for Celine.
But Steffi was wonderful and she could answer the questions.
Okay,
the question
perfect.
is English was, how can we handle the premix of the zinc oxide with the emollient without losing too much raw material? And Steffi gave a very nice answer. Yeah. I let you answer, Steffi.
Yeah, and yeah, in general, I have to say you do not use very much material by using the triple roller mill. Sorry, if you use an homogenizer, you will lose more, I think. You have to clean up and so on. And yeah, so in general, we made really good stability results with it, and that's why we use the triple roller mill.
Yeah. And also there's a question, does the triple roller mill have any specific advantage compared to just using an homogenizer? And yeah, you answered also, Stephanie, that you will have less material loss and that it's possible to work under clean and material saving conditions comparing using a homogenizer. So this is all lab focused, and maybe I can also give some knowledge to you about our bead mill, which is the equivalent in our transfer from the triple roller mill. And it's also about the product loss. As Martin already mentioned, we have a very narrow gap, and due to that, product losses are really reduced. And in addition, the advantage using milling is the particle size reduction and also the increased stability due to the particle size reduction. And in addition, or an effect of the particle size reduction is also an increased viscosity, which gives a better stability.
So there's another question. Maybe that is more for the for ProXES.
Yeah. So the question is, you would not recommend to use the homogenizer of the emulsion plant in terms of just adding the zinc oxide to phase A directly. So as we said, it is also possible to skip the milling and just, let's say, prepare the zinc oxide with a processing unit like the Dynex, so feeding the zinc oxide powder in the oily liquid phase with the work of the homogenizer and suction via vacuum. This depends always on what quality the powder has, what is the initial particle size, and what stability you would like to have. So we disperse with the homogenizer homogeneously the particles, but we do not reduce the particle size like a mill could do. Yeah? But we already made with several customers, for example, also zinc oxide ointments where we did not had any grinding prior to that. So we just used our processing unit and dispersed the zinc oxide. Also, it was a very high amount, I think around 35%. And yeah, it depends always also on the application for sure.
There's another question. If you get the material of our webinar today afterwards, yes, of course, you will get all our presentation material today after our webinar.
Okay, do you have any more questions? We have some time, some time left. So no more question? Take the chance. Okay. So then I would say thank you very much again. And as last slide, I would just give you our contact slide here. You can scan the QR code if you have any question in terms of processing. So there's one question more I could see. Okay, do you have experience what the maximum of amount of xanthan is that you can introduce into water with your plants? Okay, I think this is more referring to ProXES, I guess. Or do you want to say something about laboratory scale? Maybe do you have experience?
No, I have to check before with
Okay.
our lab team. So
Okay.
at the moment.
Yeah, I can say something. So we need to defer for sure the segment where we are working. I can tell you something also from food, for example. We had also some food products where we got up to 0.5 to 0.8% of xanthan, but then the rheology is quite silly. So it's I think you can add even more, but yeah, the behavior is not that desired anymore. But in personal care industry, there are also different kind of xanthans available, and I made also already trials with using 0.3, 0.5% of xanthan. Martin, do you have maybe some?
I can confirm what Mark says for the powder induction system. As we do not have an additional support by an active vacuum creation. So the limit here is somewhere between 1.5%. And in an integrated vacuum processing machine like the Dynex, even 1.82% are possible. But beyond this value, for sure, it doesn't make any more sense to add more because we are coming in the semi-solid stage. And this is not an realistic application anymore. But I think this gives you an idea about the capability of the equipment.
Yeah. Maybe one addition from my side. When processing hydrocolloids like xanthan, as I mentioned, you have to be aware of the feeding rate and the shear rate. So the strategy is to carefully feed the xanthan directly into the shear zone, that we avoid having any kind of lumps during the introduction, and only giving a portion by portion to the homogenizer, and then you will receive also good results.
Yeah, that's the same what we did in the lab, or we always do in the lab. Yeah.
One other strategy, by the way, can also be to pre-disperse the xanthan if you have any problems to disperse it in a kind of liquid where it is not soluble. So oil or glycerin with a low water content, or polyethylene glycol. Okay, so maybe the last slide is for IMPAG again.
Yeah, at this point, I just want to say thank you for your attention and the big interest into our webinar with ProXES today. And if you have more questions, or if you need products or samples or some assistance in processing in the lab, or also on ProXES machines, please feel free to contact us at our IMPAG offices or at ProXES. And unfortunately, we have to say bye now, but I hope we will see all of you soon.
Yeah, thank you very much. Also from ProXES side, it was a pleasure, and see you soon. Thank you very much.